Well, I'm gonna restart. Gonna keep going here now and driving it. I will record, what happened, because it's this stuff, to be driving and recording. So we're gonna record about any changes now. CMP, camshaft position sensor, signal, and ground. I'm using a sensor ground to get a cleaner signal. And right here, I have the injector number 1 current control. You can see here I have same on the screen. A channel, blue channel, equal to crankshaft position signal, camshaft position signal, red, and this is gonna be the green color for the current for different waveforms. Okay, let's go and analyze that one on the screen. Let me pause that one. We have here one event of the can E60 right here, and we can see the injector time. This is a diesel, so they welcome to the channel. Today we're gonna be working on this vehicle. This is a Dodge Ram diesel 5500. Customer concern: overheating, lack of power, and check engine light on. So we're gonna go through the process of diagnosing this, find out what's wrong. We're gonna start with scanning for coils, and we're gonna go from there. Let's verify. Check engine light on. They flash, huh? It's not on right now, but we're gonna scan for coils and go from there. Okay, well, this is the diagnostic trouble codes we have here in the system. On the PCM, we have the P0692, cooling fan 1 control circuit high, and these are gonna be for the HVAC system. So those are the only diagnostic trouble code we have. So these might be related to customer concern. So we're gonna start troubleshooting that one. Okay, so we're gonna go for description and operation of the system, the cooling fan. So we have the diagnostic trouble code here. See, got too much glare here. Let me look for another place for less glare. Okay, so we have the diagnostic trouble code here. Cooling fan control circuit high. So first thing, they are giving us the diagram, and then powertrain control module, and that one is controlling the driver fan radiator. Okay, so that seems to be like 5 pins, 1, 2, 3, 4, 5 pins connectors. So 2 of them are gonna be for the solenoid style control, and the other ones, 3 more, are gonna be for like a Hall effect sensor. Okay, so here are the connectors at the fan, and here are the connectors at the computer. So basically we're gonna go through the theory and operation of the system. So basically I know what it does, but I like to read how the systems let's see, looking for the glare, trying to find out where I have the less glare. But possible causes: cooling fan supply circuit shorted to voltage, circuit open or high resisting, ground resisting, cooling fan, powertrain control module. Those are the possibilities. So active DTC, they want we to erase the coil, blah blah blah. Check the cooling fan supply circuit for a short to voltage. Okay, we're gonna go and do those tests. So basically with the wiring diagram I can do my own thing here, because and the only thing we need is that one, really important to me. Measure the resistance between the K161 fan close supply radiator. No, that is the connector. I don't care that one. I wanted to check the resistance. This one, the resistance for Yeah, that is the one. Check the radiator cooling fan, measure resistance between K161 fan closed supply circuit and K971. 161 and 971. 61. So where is my 61? Right here, K61. Fan closed supplied. Fan closed supplied. And 91. And this one, high side control. So basically, when they say high side return, I don't know exactly what they mean. High side return, I don't know what they mean. Fan closed supply. So I would think one of these two, and between pin 1 and 6, they should be one should be ground or constant ground, and the other one should be applied. I don't know which one, because I see high side here. They mention high side return. I'm assuming they will apply power, which all Dodge, I mean like Chrysler has been doing that to their actuator. They have been controlling it to a high side. So we'll be assuming that one will be constant ground, the pin 6, and that one will be a high side. Well, now we're gonna check the resistance in between pin 1 and pin 6, as they are saying here, which you have between 6 and 9 ohms. I think that's what I read, between 6 and 10 ohms. Okay, so that is very important. I think the first step is that one, and then I will command with the scanner to control that one and verify powers and grounds, and verify if the signal is getting there. If the signal is getting there, there is no reason to check power, grounds, I mean like a wiring issue or all that kind of stuff. So we're gonna start with testing if the computer is able to command that one, and checking the resistance of the solenoid. That's gonna be our beginning. 6 to 10 ohms, and in between pin 1 and pin 6, and also we're gonna unplug that one, connect a test light there, and activate the computer to find out if the computer is capable of doing that one. But now I wanted to check the freeze frame data if we have one. Gonna be reading the freeze frame data. No help here. I wanted to find out at least what parameters that one was, when that one fell, if it was a temperature related or something. But because otherwise we just have the diagnostic. Not even, it doesn't have a code here on the generic side. It only has it on the manufacturer side. Only here it has it. It's weird because it's generic code, and I don't see that one there on the. We're gonna go for data stream. Well, first, we're gonna go to activate component, system test, and I'm gonna go and activate the cooling fan and check resistance. Those two are gonna be the first test we're gonna do. What is it? Oh, it's not on system test. It's gonna be on a special function probably. Okay, it's not here. What? Reset stationary. Actuation test. Right here, cooling fan output, that one. Okay, let's go under the hood. Okay, so we have here connected in between pin 1 and 6, and we have 8.7 ohms. Cannot get a good capture here. You see that one here? I got that one, pin 1 and 6. Okay, so what does the, I think it said between 6 and 6 and 10 ohms. Those are the instructions. The resistance between 6 and 10 ohms? Yes. Okay. So we're gonna test now bidirectional control and test those same pins but at the other end here, and verify if the computer is sending the command. Gonna use this test light and activate it throughout bidirectional control. Okay, so we have the connection here. Disconnected that one from the cooling fan. Have the test light connected here, and we're gonna go to fan duty cycle. Select the weight on. Let's see. Okay, it's on. We got the activator on. So these lamps absorb like about 2 amps, something like that. So this is pretty much simulating the same actuator. So as it is right now, everything seems to be working correctly. Let me see what does it say. What's the next step on the? So we have everything yes. Is yes. We have signal yes. Replace the powertrain control module. So that's the next step here. If we follow this one strictly, you know, but make a logical sense here. I will drive this vehicle and find out if it is related to temperature, because right now this cooling fan is at rest. I wanted to drive the vehicle, and after I drive the vehicle, I'm gonna figure out if at that point if recheck with temperature. That's the next step. In this case, I'm just checking the resistance here in between the pin 1 and 6 on the cooling fan side, and this is after driving the vehicle. And as we can see here, how it's increasing and increasing the resistance. When those fail, we have to replace the complete unit in this case. So, but we gotta, you know, like, we have to drive the vehicle at this point. Only after driving the vehicle, we found out this is the issue. We can see how that one is going up and up and up. So there is no question about that one is failing. But according to the flow chart, we didn't have any issues when it was cold. So this we gotta keep in mind. The driving condition has to be done on when we're testing for components. So this was the case here. We can see that one is going up and up. 6 to 9 ohm, I believe, said the instruction for this one. After we find out on the road test and with the temperature, and then the resistance changes a lot. So the next step is gonna be to recommend to replace the cooling fan unit on this one. So that's the next step. Okay, I have that one out of here. We can see I just moved the shredder here and stuck it on the sides. So seems like they probably recently replaced that one, because, or at some point they have replaced it. There is one bolt missing, but we have the new unit here. So we're gonna install it and recheck. Well, I'm finished now with installing the new cooling fan. I already road tested this vehicle and drove it, and I did not get any diagnostic trouble codes anymore. And at the same time, what I'm looking at here, sometimes the RPMs of the cooling fan are lower than the engine speed. Let me turn off that one here. So what happened when I turn off that one? Anything changed? Not really. Well, the old cooling fan, the speed was reporting about 500 RPM when the engine at idle, when the engine was about 800. So I already drove this vehicle and did not return any diagnostic trouble codes. So as we saw, that one, the solenoid was really way off the resistance. So we're done with this one. Thanks for watching. See you in the next video. Apparently that's gonna be the problem. As we saw, it changes the temperature. With the temperature, it changes the resistance. And we checked computer control, wiring integrity, and also we checked the resistance of the cooling fan. Bye bye.